Library, and we'll be exploring two modules in the library today. So before we start off with that, all three of us organizers here, Soumya, Shermaine, Karen, we're all here to welcome you guys. Feel free to contact us. So a little about me, I'm Soumya Vemuri. I'm a final-year CSE student. So Shermaine and Karen.
So hello everyone, I'm Shermaine and I'm from Singapore, but I'll be going to Imperial College London to start my undergraduate studies in Electronic and Information Engineering this October. Yep, Karen.
Hi everyone, I'm Karen from Hong Kong. I'm the only one who's actually working. These two young generations. I'm a programmer at a research and development company in Hong Kong, and I'm doing a lot of right now. I'm doing a lot of like neural network, like video classification, like related projects.
Awesome. Okay, so the speaker for today is me. So I'll be taking over the content and the live coding for today. So like I mentioned, I'm a CSE undergrad and I've been a volunteer here at Women Who Code Python track for almost a year now. You can connect with me here in the link that I've given in the description. All right, so today's agenda. So we'll start off with introduction to the series. So a little intro to what you can expect from the series, what we'll be covering. So a little introduction to that, what requirements are there a few before coming to the series, the sessions. And then we'll start off with what is Python standard library. So we'll be exploring two models in that today, a little setup, and then we'll jump into hands-on coding. So before we start off, feel free to use the Q&A board to drop in any questions, and me, Shermaine, and Karen, we're here to answer all of them for you. So you can send in your questions there. So let's start. So welcome to Python Libraries 101. The series will cover a range of popular Python libraries used every day in over a range of fields. So each session will start off with a conceptual presentation. So we'll have a little bit of theory, introduce you to what we'll be exploring that day, and then we'll jump into code walkthroughs and hands-on implementation of various functions and variables that the library provides. So each session will be held every week, so at 10 a.m. EDT. So first we'll be starting off with the Python standard library because it has a range of tools that we could use. So the next couple of weeks we'll be exploring different modules in the Python standard library in itself. So today we'll be doing OS and Sys, and then we'll jump into math utilities like statistics, math, random. We'll be doing data type libraries like collections, iter tools, and also time libraries like datetime and calendar. So and right after we're done with the Python standard library, we'll be covering other topics like data visualization and data analysis libraries. So we have NumPy, Pandas, and the plotting libraries like Matplotlib, Seaborn, and Plotly. So you can expect that to be followed right after we're done with Python standard library. We'll also be doing another range of stuff like GUIs with tkinter. We have computer vision like OpenCV and Pillow. And there are a lot more that we have planned for the series, so you can stick around for those. Awesome. So let's start with Python standard library. Feel free to leave any questions along the way, and Shermaine and Karen are there. They'll pause if you need me to slow down a bit, or if you need me to reiterate something that I've already said. Okay, so yeah, Python, it offers a lot of built-in functionality. That's one of the main things that it's known for, that it really makes everything easier for us. So there are a lot of built-in modules that are written in C, and they're integrated with the Python shell. So the standard library in itself is a huge collection of utilities. So like I mentioned in the previous slide, there are math utilities, there are timed utilities, It gives us graphical user interface utilities. So the most popular ones are OS, Sys, JSON, re, which is basically a regex utility. There's random, so yeah, math, URL lib, tkinter, and datetime. All right, so first we'll start off with the Sys library. So the Sys module provides functions and variables used that we can manipulate different parts of the Python runtime environment. So when you run your code, there are a lot of things that you can probably work around that. When I show you a function and a variable that it provides, you'll get a better idea and an understanding of what that is. So the Sys module, it provides us access to the variables and functions that interact strongly with the interpreter. So basically, most of you might know this, but Python is an interpreting language, unlike C, where we compile the code and then we run it. In Python, there's an interpreter. So each line is run one by one. It doesn't go through the entire code, look for bugs. It goes line by line, and if it finds a bug, then the code stops. So that's how Python works. So yeah, so for example, one of the functions that the Sys module gives is Sys.argv. So if you're familiar with other programming languages like C, we have an arg extension where we can get the name of the function that we're running and command line arguments. So that's something that we could get in Python as well using the sys.argv. So we have argv and argc in C language. Over here we have just argv. And yeah, we'll be exploring that, but it has a combination of both of those, argv and argc. For people who are new to programming, it might be a little confusing, but I will explain what these command line utilities, command line arguments are. I'll show you as well. This is just an example for now. And the syntax is we just import the module. So when you install Python on your system, you already have Sys in the thing. That's what we say when we say Python built-in modules. So you don't really have to install it separately. It's a built-in functionality when you download Python and install it. Yeah. So yeah, Sys module. So it offers us with a lot of variables as well as functions. So a variable is basically you can get some values back when you run the command. So sys.modules, when you run this, it displays a dictionary. So the key value pairs in this dictionary would be the module names to the modules which have already been loaded. So, and then we have sys.platform. So it displays a string containing the platform identifier. So it's basically what platform you're using. That's what you can find out using sys.platform. A lot of this might feel like a lot of theory coming in, but everything will get clear once we start running these in the Colab notebook or in your interpreter. So we also have sys.version. So it will tell you which version of the current Python interpreter that you're using. And we have sys.path. So when you set your environmental variables, you can access all of them and see what they are through the sys.path command. And then we have a couple of functions that we can use. We have sys.rv, like I mentioned before. It's one of the, it's where we get, so when you run the Python file in the command prompt, for example, you can also give command line arguments right there. You can say, I want to run my name.py, and then you can give your name after that, and it'll print, and you can write the Python script to say hello, Soumya, for example. So you can send variables and such in the command line before you run the code. So that's how you could use sys.rv. We also have sys.Getsizeofobject. So like you probably know, Python is one of the object-oriented programming languages that are popularly used, and the most major part of this is that Python, everything's an object. So even if you're declaring a variable for an integer, it's an object of the integer class, right? So you can get a size of any of these. You can get a size of int. You can get the size of characters. So it's pretty much like the other size of functions that you see in the other languages, programming languages as well. So we have Sys.Stdn. It's basically the standard input. So you can return the input directly from the command line. You also have stdout. So it's standard output where you can display the output directly to the output window. And then we also have Sys.Exit. So if you want to exit from the Python console or the command prompt, you can use the Sys.Exit. The argument would be a message that you want to print when you exit. All right, so we're done with Sys. That was a lot of theory at first, but don't worry, we'll be getting into the live implementation soon. So first off on OS. So the OS module in Python provides us functions for interacting with the operating system. So these functions would be, creating or removing directories, folders, for example, creating files, getting the content of files, changing and identifying the current directory and such. So again, just like the Sys module and every other module in the Python built-in libraries, you just have to simply import OS. You don't have to install it after you've installed Python. So we don't really have variables as such in here, or the ones that are there aren't that popularly used, but mostly there are functions. So you can do os.get current working directory or get cwd. So the current directory that you're working in, it returns the name of that. We also have os.make directory, mkdir. So you send the argument of the path and the file name. So that file name is optional, and you can mention a path, and even if you don't mention a path, it'll make the new directory in the current working directory. So people who've used the Linux shell before, these will probably be very similar to what we've used there as well. But Python also offers that functionality through the OS module. So we also have change directory, we have remove directory, we have list all the directories in the path specified. Every time there's a path argument, if you ignore it, it would be the current working directory. We also have os.rename, so you can rename the source and the destination, and you can mention the destination name as well. We also have os.open, so you can open a file, and this would return a file descriptor. So it's kind of like a pointer to where the file that you've opened is. So that would be the fd argument in the next function. So os.fetch directory. You can directly jump to that directory using the file descriptor. We also have os.environ. So it's used to access the environmental variables. A huge list of environmental variables is returned through that. You also have put env, so it sets the environment variable named key to the value string. It's kind of like, setting the path for a particular variable. And you also have os.path.join. So it concatenates two strings together to make it a path. And then you can probably use os.open to open that path. All right, so if you have any questions, do drop them below in the Q&A or in the chat. We'll answer them for you. And right after this, we can go into live coding.
Thanks, Soumya. Maybe we can give 1 minute to anyone is typing in the questions, so you can answer them.
Padmaja, you can use PyCharm. It's a little heavy on the side for what we're using, so I wouldn't be using that today, but you can definitely use PyCharm as well. So yeah, you can learn it in PyCharm as well, but I'll be sending a simple collaboratory link, so you can do it in that as well. Yep, Jacqueline, we will upload the video to YouTube. It might take up to a week or a little more. Okay, Karen already answered that, so awesome.
So for anyone who's new, this is the first time here, we usually do our live coding session using the Google Colab notebook, which we will be sending you the link very shortly. So if you want to this is a good place for us. This is definitely a good place to start. You learn coding because you don't have a lot of setups that you need to deal with, and also you can use it on the web browser. You don't need to download anything at all. So if you're looking for anything specific like a coding place, and then you don't have any preference, that we would suggest you to start it from there. And also you can get used to like coding with us. Sorry, Soumya.
No. Yeah. So Padmaja, the session would range from around 45 minutes to 1.5 hours, 1.5 hour tops. So we don't want to tire you out or anything. Annie, yes, I'll be showing all the functions right now. Okay, so before we get into live coding, 2 points. So like I mentioned before, one would be we would be doing the live coding in the Colab, but there are also some parts that we do need to use on our system. So hopefully all of you guys have Python installed. And if you do, it comes with a built-in editor called IDLE. So you can probably use that later on. If you want to run files and such. Okay, so yeah, so what you guys can do is you can make a copy of it. So save a copy in Drive. It'll create a copy and it'll redirect you to that copy. So you can do this and you can code along with me. So if you've got it set up, leave a thumbs up in the chat and we'll get started. Awesome. Julia has it set up. Awesome. Everyone looks like awesome. Thank you, Jenny. You can also leave the letter B as a thumbs up. Awesome. Looks like everyone's ready. So if possible, you can go on split screen. So you can do it parallelly with me. If you need me to slow down, do let me know. You can put it in the chat, and Karen and Shermaine, they can stop me and I'll take a pause. All right, so make sure that the runtime's connected. So yeah, it's connecting. So now we have the list of topics today will be the Sys and OS modules. So yeah, so the first one, it's basically importing Sys. So you can't work with the Sys module or any of the functions or variables of the module without importing it first. So do make sure to always remember to import the Sys module. You don't have to install it separately. Yeah, next we have Sysdot version. So like I mentioned before, it displays a string containing the version number of our current Python interpreter. So ours is GCC 7.5.0. All of this probably isn't that necessary for us, but it's always important to know all of the functionalities when we're using a language. So just a little, a little pointer, I guess. We also have Sysdot modules. This will be a really long output. It's a dictionary, like I mentioned. So it maps the module names to the modules which have been loaded. So we have Sys, and this is the module that it is that's been loaded for it. We have built-ins, and that's the name for that. And then we have sys.path. So it displays an entire environment variable. So these are all the environment variables present for the Python, for all the Python modules that we have. So when you run a particular Python file or a Python command, it'll look for its instructions in these paths first. And if it can't find it, then that means that you don't have it installed and it doesn't know what to do. So that's why we have to have import sys. If we don't do this and we run any of the sys functions, it starts looking in all of these paths. It doesn't find it. It doesn't even know what path to go through. So yeah. Or if you're trying to run any other file, another library that's not built in and you don't have it installed, it won't find it in these paths, and then it'll cause an error. And then last is platform. So it's Linux. So usually most of the cloud-based tools or utilities are all hosted on a Linux server. So our platform is Linux. If we do the same thing on our system, it would definitely, so mine's Windows, so it would definitely say Windows. I can just do it on ideally. So I'll just show you that as well. Can you, I don't think I shared my entire screen. You guys can't see my other window, right, Karen?
We need your collab right now.
Yeah, okay, I'll just reshare to my entire screen. All right, it should be visible now, right?
Yes.
Awesome. Yeah, so if you have Python installed, all you have to do is look for IDLE. It's a built-in editor. If you're familiar with other ones like Sublime, Atom, and all. So we have IDLE by Python. So yeah, like I mentioned, we have sys.platform on the cloud. It's Linux, so we can try it on ours as well. Yeah, so you see, I didn't import Python, import sys, so. So yeah, it's Windows 32. Feel free to drop in which one you guys got. We'll see how many Windows users, how many Mac users we have over here. So I'll take a pause for like 20 seconds to make sure everyone's all caught up. Awesome, we have a lot of Windows users. I'll be surprised if I see a Linux user over here today. Yeah, so I'll just repeat again. You can just go to your start and you can look for IDLE. If you have Python installed, it should open up. Wow, Srishti is a Linux user. That's amazing. So like, kudos to you if you're able to, navigate through that. See, there's a Mac user. So awesome. We'll get into the functions part of it now. So those are basically the most popularly used variables. Yeah, so argv0. So we're running this on Colab, so it really won't be that useful, but let's just see what this would do. So this is what we get. So basically argv0 is the first argument from the command line argument. So when the Python file is run, this is the first argument, which would be the name of the Python file. So it looks like this is what the Colab does. It created our Python file in this sequence of directories, and then the file name seems to be ipy kernel launcher. So let's try to do one on our desktop. There's a code over here that you guys can copy. You can open up a new one in the editor over here itself, or if you wanted to use any other editor of your choice, you can feel free to do that. Just for simplicity, I'll just do it over here. So a new one over in the Python, ideally, I'm just going to copy in the code here. So let me know if you guys got it set. Yeah, so if you guys have got this set up, just save it in a place that's easy for you guys to go to, because you will have to change directories, and we'll be using the command line or the terminal basically to run this file. So yeah, so as you guys can see, the file is basically just going to print your name, and you're going to give it the name in the command line argument. So let's just name this myname.py. And I'm saving it on the desktop so I can easily move into that directory when I open the command prompt. All right, so like I said, sys.argv0 is the Python file's name, and every argument after that we send in is a command line argument that we could use to modify any part or use the variables or values. So I'm opening the command prompt. If you need me, if you're unfamiliar, you could just do cmd and it should open. Mac users will have something else, but I'm not really sure what that is. But I think terminal is like very accessible for you guys. So yeah, I'm moving into the desktop, and my Python file's name is myname.py. Yeah, so now we're just gonna have to run it. So when you run it, you have to do Python. Some places might have Python 3. I think Ubuntu and stuff like that, you do need to mention the version. So if you do get an error, you can probably try that. Don't forget to put Python before though. And then myname.py, the file's name. And then you can put your entire name, put one name, you can put one character. So we're sending in our name. So my name is Soumya Vemuri. So I'm sending in the name, and then I'll hit run. And that's what it shows. It says that the name of my file is myname.py and my name is Soumya Vemuri. So it returns a list basically, because what I'm doing here is I'm putting everything from index 1 to whatever the end is. So that's why I'm getting a list back where the first argument is cut out. Yep, Shrishti. So, in Ubuntu and Linux, you would have to use Python 3. And looks like for Mac as well, you would have to have Python 3 before. Awesome. So this is how we use command line arguments in Python. You don't have any other way to use them without, importing the Sys library and using the argv extension. Usually this would be argc in other languages, or it's the other way around. I think I was right. Yeah, so this is basically how it's done. If anyone needs me to pause for a second or repeat, do let me know. Okay. Let's move on to the next one then. Yes, Srishti, you're awesome. Yes, you're right. Okay, looks like everyone's got that. So we'll do the next one now. So yeah, so what we're gonna do is we're gonna use the get size of, and in Python it's a little different. The sizes that you would get. So usually in other languages you would see, each character would be one byte or something like that. It's a little different here in Python. So let's see what it does. So let's try different data types. The first one we'll do Python libraries 101. You can put whichever you'd like. I'm just gonna put some generalized name. So our session number, we're gonna use an int value. So let's do 1. The topic we're in right now would be 1.1. And then the list of topics today are, as you guys know, Sys and OS. So we're trying to use strings, ints, floats, lists. We'll also use a tuple. We'll do the same with the tuples as well. Just so we don't get confused, let's just try using it the other way around. Okay, so we're saving different data type values. You guys can use anything else of your choice. Python libraries 101, we have a string with a number of characters in it. We have an integer, we have floats, we have a list of strings, a tuple of strings. So let's see what the size of these would be. So as you can see, it's a lot larger than what you would expect. Suppose this was just 10 characters long. You would expect it to have 10, but that's not the case here. It's like 69 bits. So this is a little weird with Python, but this is because in Python, like I mentioned before, everything's an object. So even when you're making a string, it's an object of the class string. So a class would have a multiple number of functions. So each time you have a string, there's a copy. It has its own functions, assigned to that. Because of that, it's super heavy. As you can see, just a string in itself is 69 bits, an integer is 28, whereas it doesn't go beyond 4 or 8 in any other language. I mean, worst case, it's 8, right? So let's just see what the empty strings and just an integer is. So what I'm doing here is just a string instance, just an integer instance. We'll see what an empty one looks like. We'll see what the size of the empty one is. So this is how big they are. Just an empty string is 53, and an integer with no values is 24. A float with no values is 24. So yeah, you can also see how different it is between a list and a tuple. Even though they're storing the same values, there's a difference over there, and that's because lists have a lot more functionalities than tuples. So sometimes when you're coding and you don't have to use when you don't have to change the values in a certain data structure, it's always better to go with tuples because they definitely will be faster. If you don't have to add more values to that particular data structure, you can use tuples and it'll be faster. As you can see, there is a huge difference just between the empty ones. There's at least like over 15, I guess. So yeah. Awesome. So let's move on to the next one. Why are they so big? And see, yeah, exactly. So like I mentioned, everything here is an object. So usually, let me just create another cell. So usually what would happen is when in other languages like C, Java, or any languages, when you make an integer, you're storing a value in a memory location. That's it. So what it would do is if the number is just 2, you would only need a maximum of 4 bits or 8 bits. But if it's a longer number, you would need a little more number of bits. But when it comes to Python, just creating an int itself is actually an object. So suppose we have a class. So a class is basically a template. What integer actually is a class. And suppose this is its constructor. So it's a huge template. I think I got def. Yeah, so it has like a bunch of functions. So for an integer, when you want to modify an integer, you would probably have some easy ways to get through it. Or for a better understanding, let me do lists. Okay, so in other languages, for example, C, an array is just a sequence of it just looks for a sequence of empty memory space and it puts the values in there. But in Python, it's an object. And so suppose this one would be name. Okay, it saves the name of the list. But then you would have so many other functions, because if you're familiar with lists in Python, you would have append, you would have that concatenate, so it'd probably override the plus operator. You would have things are not coming at the top of my mind, but you have pop, and you would have a lot more for lists, right? So I think, okay, yeah. For example, these. So you have all of these functions. So every time you're creating a list, you're creating an object of this entire template. So this whole template is being saved in that one instance of that class. So you have all of these saved plus the values. So that's why it's super heavy. All right, I hope that answered your question. Here I said list and it shows 400, the built-in list. $400, so I guess the empty list for you is 400 bits. It must be that big. That's huge. Did you add a lot more values to your list? No, okay. Well, that's weird. I have no idea why 400. That's such a huge number. I'll see. I'll get back to you on that. It's not defined. Oh, okay. The empty one in itself. Wow. I'm not sure why you got 400, but I will check that out and get back to you. Or maybe Karen and Shermaine, if possible, if you guys know, you guys could probably answer that. Okay. You just did an empty list like this. Ah, okay. That's, yeah, Karen.
I'll take care of this. So I think the problem is probably I assume you guys are on the get the list of topics. So what are you pulling? Sorry, Pimaja, you're pulling off the predefined value actually of the list. So list itself is a predefined string in Python, and where Soumya is doing is if you can see the seventh line, this one is like, so the list, you have to type the list of topic, which is like a self-defined function, a self-defined value, which if you go a little bit upward, Soumya, so you have to predefine it right there.
No, what she means is, you see the one over here, right? When I just do get size of list, it's returning 400. The size of that is 400, just a list. So what I assume is because when we do list, it looks like everything the whole size of the list class in itself is being printed. But when we
I would assume so,
instantiate an
yeah.
object of that, it seems to be a smaller. But
agree,
I will
actually.
confirm, and maybe next time, or probably if you join the Slack community, I'll try to get back to you on that. I'll check it out. All right, so I hope you guys are all caught up by now. That's an amazing question, Padmaja. I actually didn't check that out beforehand. All right, so we'll be trying out Stdin and Stdout. So for that, we'll try to run another file again. This because we need to get the input and output from the standard input stream and standard output stream. So for that, again, you can go to your editor. I'll use ideally just for ease of access. Oh, looks like I didn't copy it. So this is incomplete. We'll be filling it in together. All right. Let me, if you're all set up, do let me know in the chat and we'll get started. Okay, it looks like people are set up. All right, so first and foremost, we do need to import Sys, so don't forget that. And then we'll start. So what we're gonna do is we're gonna make a tiny game. So it's gonna be like a lucky game. So all the user just needs to guess a random number or color. It's just gonna be a simple thing, but we'll try to get the numbers as an input from the standard input stream. So you can put a list of numbers of your choice. So we'll go with like 10, I guess. So go ahead and fill in the number. So I made a list called random items, and we have numbers mapping to a list and colors mapping to a list. So feel free to fill it in of your choice, or you can follow along with me. So I'm just going to put the random numbers here. So across different. I think that's enough. Put color, so you can make it a little hard for the people who are trying to play. I'll put one of my favorite colors, red. Put another. So black is like really common, so probably let's gonna skip that. Let's put something tough like turquoise. Is that the right spelling? Yellow. Eggplant. Beige. So I'm putting like really hard colors. You guys can feel free to put anything you want. Olive, maybe two more. So indigo and orange. All right, so these are my colors. You guys can put whichever ones you would like to have. Teal, aqua, Okay, so once you get that, the next one would be name. So because we learned how to get the name from the command line argument, let's try to do the same over here. So as you guys observed last time, we got a list, and kind of looks ugly when we have the list over there. So let's try to make sure that we don't have a list, but we have a string that's being printed out. So we're going to use the join function. So make sure that you have a space here. So what we're doing is join the string, which is an empty string with a space, and I'll explain why a space in a second. And sys.argv, and from 1 onwards. We don't want 0 because that's the file name. All right, so from the first argument onwards, join it into the string. And why I'm putting a space here is that for every element in the list that this is returning, it puts a space in between. So it's not going to be Soumya Vemuri with no space between the two names. Okay, so after that, we're going to use simple print statement, hello name, and we're going to print guess a number or color to win. So after that, what we're going to do is for line in. So over here, what we want is to get what the user is printing, inputting. So it could be a number or it could be a color. It's their choice. So we're going to have to render that on our side. So this is where Sys.Stdn comes in, Sys.Stdn. And you might have a question on why do we need to use this? We have print and input as well. This is just another way to get the input from the command line input stream. You can obviously use input. So this is just another way to see how we could get input from the through the Sys module. So Sys.Stdn. So for every line in that. So we have our current line now, and like I mentioned, we're going to have to render it on our own. So current line equals to lines dot strip. So what will happen is, so what's going to happen is when you run the file and you give an input. So suppose you give one, and then you click enter, right? So after you click enter, that's when it takes the line in. So after 1, it's automatically going to save a \n because you clicked enter for new line. So we're going to have to try to remove that. All right, so once we've done that, we'll also add a small piece of code just in case the user is tired of playing. So if they typed quit, like, I mean, the game was too hard for them. Quit. Oh, if current line is equal to quit. We're just gonna break out. So we'll just click a break, come out of it. Yeah, so otherwise, if the current line is numeric, so current line dot is numeric is true, then what we would want to do is first convert it to int. So we're doing a typecasting. So we're converting it to an int, and we're going to check if it's in numbers. If it is, then they win. So we're just going to print you win. Else, we print try again. And the same way over here, if current line is in random of colors, we'll print you win. Otherwise, we'll do try again. And one thing that we need to make sure we do is let's convert the current line to lower. So we can do that up here too. So even if they type black, black, or black, or black, we want them to get the point, even though they're making type a weird case. So we'll just change it to lower real quick. So current line is equal to all right. So we haven't used std out over here. So let's let's do it at the end. So once we're done playing all of this, we'll just let them know that they've won and now they're exiting the game. So we do sys.stdout.write, and then you can print a new line first. Plus. All right, so this is our code. I hope you guys are caught up. So what I'm going to do is, again, for ease of access, I'm going to save it on the desktop. So lucky game dot py. Okay, I don't have to do the dot py part. Does it for us. Okay, so if you guys are all caught up, you guys can run it. So cd desktop and then Python lucky game.py. And remember, we gave in our name, so just type a name over there so that it can welcome you. And so I'm just gonna pause for a second just in case people aren't caught up or needing it.
We have a question.
Uh-huh.
So Heidi is asking the Sys, so Sysdot Stdn, so Stdin. Do we need the parentheses like the bracket?
So no, we don't, because over here we're not calling a function. This is a value. So from the sys, we're getting the value. So you don't need a function call over here. It's returning it's a variable. So you just have to use this. And then sys.stdout, it's again a variable, so it's an object of this point, and then it has a function called write. So we write it into the output stream. So that's why we need we have a parenthesis here, but we don't have one here, right? Because we're not doing a function call. Okay, Jacqueline, I can stop for a second. But if you guys want to, jump for it, I'll send you a link. We have the code there so that you guys can also do it along with us. So we have all the resources here, and I'll link it towards the end of the session as well. But you can copy over the code, so it's the same code that I'll be using right now, just so that you can, you're not left behind. So I'll put it here. You guys can copy that code over, and then we can all run the code together. Yes, you can probably see it now, right? Yep, okay, awesome. If you guys haven't caught up yet, feel free to copy the link or copy the code from the GitHub link that I sent, and then leave a thumbs up, and we'll try to run the code together. A box. Ah, okay, probably this. Okay, a lot of people have said that they've caught up, so awesome. Okay, so let's run it. So you can go to your command prompt or terminal. You can move into the directory that you've saved the file in. Preferably the desktop would be more easy to access. And then make sure you run it. Make sure you put your name there so you could just see how we're able to join multiple names. So let me just put my entire name there and we'll see. So last time we got a list. Well, we'll see if it's going to join it together and put a space in between each name. Okay, so let's run it. And it did work. I'll guess a number, a color to win. So let me say black. It says try again. Let me try something else. Like, okay, we'll try teal. So Stephanie gave that number to that name to us. And also I'm capitalizing the T here, and in our list it's a lowercase, so that it should work nonetheless. And it says I win and we're exiting the game. So that's a simple way to use this. Yeah. So this is how we work around the std input and output functions. You can also see why it's different from print by replacing this with sys.stdout.write. It just makes it a little weird and messy, mainly because, Stephanie probably answered the question as well, that this is directly printing it in the sequence of the Python program, and this would be in the output stream. So yeah. So if you guys explored this, we'll try to extend this to another another level. So we're going to use the sys.exit. So sys.exit is used to exit to either the Python console or the command prompt. So we're gonna so we have break statements here. We can also try to use the exit functions as well. We'll make the game a little harder. So what we're gonna do is, if the person has guessed for too many tries, we're gonna exit from the code. So what we're gonna do in that case is we're gonna have to put an if statement in between. We're also gonna have to have a counter. So we're gonna just put a simple counter over here. So we're gonna say count. Okay, we have to have it outside, sorry. So we're going to say count equals to 0, or a counter is equal to 0. And then we're going to count every time they get the wrong answer. And so we get a wrong answer every time there's a try again, right? So we're just going to do counter is equal to counter plus 1. So this is one place where I change the code right outside the for loop, and then again right above the try again. So we're just incrementing the counter, and again here. So another way to do the counter plus 1 is just plus equal to 1. So when that's done, we're going to have to make sure that the person is not going for more than 5 tries or 3 tries. It depends on how hard you want to make it. So if counter is equal to, let's give them 5 because, like, numbers and colors, any one of those. What we're going to do is we're going to use the sys.exit. So sys.exit. And just so they don't think that their computer is bugged or something, let's leave a message so they know why the game stopped. So we're saying you're out of chances. Better luck next time. Okay, that's it. So all we changed is we put a counter outside. We're incrementing a counter here. In both the cases where there's a try again. And then we're just doing an if counter is equal to 5. Exit it and make sure you leave a nice message for them so they don't get worried that it just stopped abruptly. Okay, so let's go back to our command prompt again. You can also run it here in the IDLE, but you won't be able to run the command line arguments in that case. I'll also show that right after this is done. So cd desktop. So guess a number or color to. I'm just gonna try to lose this time. So 2, nope. 3, nope. 5, nope. 6, nope. 7, nope. Looks like the counter. Did I try 5 times?
Soumya, do you save your code?
I did. Probably didn't. You're right. Okay, rookie mistake. Anyway, so sorry guys. Okay, so I'm running it this time and I should lose. So first time, no. Yeah, so it shows the message and it says you're out of chances, better luck next time. And as you can see, we're not getting the exiting game because right after the system.exit function is called, it's just going to take you out of the program or the interpreter that you're in. So yeah, that's how that works. Yeah, that is what would happen. So a little hard, making it a little harder wouldn't be a bad thing. Okay, so we're done with Sys. We'll go into OS real quick. I hope you guys have caught up with that. So for OS, we're gonna have to run the import OS module. And now we're gonna, do some playing around with the operating system. So first, let's see what directory we're in. So we're going to do that with the getcwd. And we're in the content folder. So that's how Colab is going to save it in the content. If I did the getcwd on my desktop, it would show me desktop. So you don't have to follow along for this, but I'll just show that real quick as well. So when you want to do Python on the command prompt, you should type Python or Python 3 first, and then so it shows the path that I'm in, the absolute path. All right, so next, let me list the directories that are there in the content folder. And these are just random, these are stuff saved by Colab itself. It's nothing that we have to worry about. So what we can do now is we'll try to create a new directory. We'll make a new directory for this. So for that, we do os.mkdir. And then we'll just name it new directory. So you can also have a file name or a path specified. It's all up to you. So if you don't mention anything, it's just gonna make a new folder in the current directory that you're in, and then we'll just print out what the current directory to see if the new directory was made. So it has. Yeah. So suppose you don't like new directory because after a day or two it's not new anymore. So let's try to rename it. So we would rename it using the os.rename function. So source would be new directory. I think I have to use. And we'll just name it my files. All right, so let's just list the directory again. os.lister. And it changed the name. So the directory name has been changed. All right, so the next one would be switching directories. So let's try to move into the My Files folder. Yeah, so change directory would move us into the My Files folder. So os.chdr. and we mention what the file name is. So over here, it will be my files. Yeah, so basically it just switches the current directory. Let me just put here, it looks better. All right, and then we'll just see what the current directory is to make sure we actually moved into the My Files folder. Oh, okay. Yeah, so as you can see the path, we're in My Files right now. So that's how we switch directories. We move into that using the cfdir. Next, we would be opening a file. So we don't exactly have a way to move out of this directory, like how we would just do a cd in a Linux shell and we can move back, or even in the command prompt. So what we would do is we can put a pointer or a file descriptor. And what this would do is os.open, as I mentioned in the slides. So what we're going to do is we're going to make a pointer to content. And this has a different number of modes that we could use. So we'll do os.o read only. So it just says that when I want to open the file, I just want to open it in a read-only mode. And then so it gets saved in FD. And what we're going to do is os.fetch directory. So we want to move back into content. Yeah, os.open content with the o_ read only mode. And then we're going to fetch that. So, oops, okay, yeah. So now we're moving back out. So our current directory is again content, and the composition of the directory is the same thing as we saw before. So let's get rid of My Files for a second. Let's remove it. So how we would delete a directory is rmdir and then My Files. And just like every other OS manipulating mechanism, it has to be empty. My Files has to be empty in order for you to be able to delete it. And when you take a look at the composition again, it's been deleted. All right, let's do a little more stuff with the directories modification. So we're gonna make My Files again. We're gonna move into My Files, and we're just gonna see where we are. So when you run that, you see that you've moved into My Files. So it's been recreated, and then you're in it. All right, so what we're gonna do is we'll make a couple of more directories in here, just to see if we're able to delete a non-empty directory. So let's just make a couple. So you see in My Files, we have stuff like videos, photos, documents. And so once we make these, we'll just see what the composition of My Files is. And since we're currently in My Files itself, we don't have to mention the path of that over here. So yeah, we have videos, documents, and photos. All right, so next we're gonna see, we're gonna switch back. So our file descriptor FD was already pointing to content. So we can just run this one directly. So as we can see, the composition of our current directory is My Files. So we moved out and we have videos, documents, and photos. So now let's try to delete the directory My Files. So as you guys can remember, os.rmdir my files. This should throw an error, and it did, and it says it's not empty. So this is something we can't do. So yeah, so when we want to remove those, so now what we would have to do is we have to empty the entire directory, and then we have to delete it. So let's first save the path. So we do this by mentioning the entire path, since we know it, it's easy. So it's content, My Files. And what we're going to do is, because we can't keep adding stuff like photos and documents every time, we're just going to keep this as it is. Try not to use the / over here as well. We'll see what os.path.join does for us. Or actually, we do need to add it. My bad. We'll try to delete photos. So you can just have the path there and it should directly concatenate. It's kind of like a basic string concatenation. So, and then it deletes it for us. So the same way we could delete videos and documents as well. And then now it's empty. So we'll just confirm that by printing the next one. And it's empty. So now we can try to remove my files and it should say that it's no longer there. And yep, as you guys can see, the current directory has been emptied out. So yep, so that's how OS and Sys modules go in the Python standard library. It might be a little boring and stuff, but sometimes when you're opening files through your code, you would definitely need to use the os.open. Sometimes if you want to get the path of the current directory you're in, and then attach the file that you created its name, you would probably use path.join, stuff like that. So it will be useful along the way when you're doing a lot of coding and stuff. It's just basic, you know, knowledge that you could probably use later on. So yep, so I'll link the repository. So we've uploaded, you can get all the content that we've used today in the repository. Let me just minimize this. Okay, so we have at Women Who Code Python's repository, you can find Python standard libraries. We'll link you to that, so you can probably find it here. And we'll be uploading our content every week, so you can just click on the link here for whichever library you're interested in, and you can find the material for that. We have all the codes and the slides and the collab uploaded. And once we have the second session recording up, we'll make sure to add the link here as well. So, yep.
Great. Thank you so much, Soumya, for the amazing and very informative section. I definitely agree with what Soumya says. Sorry, like these two libraries seems are very undermined. Like it's not as like sparkling like NumPy and Pandas, but they are very, very useful when it comes to like when you do a lot of coding. Hope you guys enjoy it for the first section. And remember to follow us on social media. We are on Instagram, Twitter, LinkedIn, and we do have a Slack channel that and all of us use to communicate everything with. So if you have any questions that is later, they come on later when you try during the recording, feel free to join us and like pin us on the Slack channel. That's Stephanie sending in. And maybe we'll give like 1 to 2 minutes for the final questions if you guys have anything.
Yep. So for the next session, we will be having date, time, and calendar modules. They're a little fun. You can get your program to sleep for like a couple of seconds just to, sometimes you're working on a project and maybe it's not working completely, but you want to show people that it's running in the background and it's taking time. You can just get your program to like sleep for a couple of seconds. So you can do stuff like that with time. You can also have date time to, work with dates, the data types. And then the session after that, which would be the week after that, we would do collections and error tools, and they're really useful modules, especially something that Python is really popular for is to make things much easier, right? So these would definitely help out, and that will be followed by random math and statistics. And like I mentioned at the start, we have a lot more lined up. So we also have a couple of other upcoming events. So we have the beginner study group on the July the 30th. So it's a Friday. So be sure to register for that. And then the Saturday, the day after that, it would be the next Python library session. And then we also have another event coming up called Open Source is Better with You in It. So it's a getting started with open source event. So be sure to register. You can register at womenwhocode.com, Python, and then events. Awesome. So thank you everyone for joining. It's amazing that you all have taken time from your day to join us for this session. Be sure to join the Slack community so that we can stay connected. We can help you guys out if you need any help or link to resources. We'll also upload the link to the YouTube recording over there. So it's just a ease of communication. So